All right, sound check. All right, hi everyone, good afternoon. I hope everyone has some energy left, no? So yun, this is my talk entitled Power Up Serverless Applications with AWS Lambda Powertools from Tracing to Generative AI. All right, so first off, a bit about myself. Hi, I'm Arnel Sarmiento. You can call me Nel. I'm a Python backend engineer at Elementa. We're a fintech company based in Sydney that builds tooling for financial advisors. I'm also an AWS certified professional with a cloud practitioner certification. I'm the community lead of Durian Pi, Davao's Python User Group, and a co-founder of PWA Pilipinas Davao. So meron kaming booth sa labas, guys, if di pa kayo naka-visit. Ayun. So in these communities, we do monthly meetups and conferences. So if you're within Davao, know that there's a meetup just around the corner sa Durian Pi and PWA Pilipinas Davao. All right, so let's jump into my talk, no? So raise of hands, guys. Raise of hands. Who here are developers? Developers or may experience sa software development kahit paano. Okay, I see a few here. How about backend developers? Raise of hands. Kahit nakatry lang ng backend, any backend. Ayun. Okay, medyo marami-rami. How about backend developers na may serverless experience? Raise of hands. Okay, so it's good that I see a few here. Okay, so yun. If ever may kayong experience sa serverless, you might learn a new things. But if ever, medyo new kay serverless, this might be a bit new to you, the topic. All right, so in my talk, I'm gonna start it with a refresh in serverless, like pabilisan lang na refresh. I'm gonna proceed with a Serverless Application Lens for the AWS Well-Architected Framework, which is a service in AWS. I'm going to dive into Power Tools for AWS Lambda. And then the features of Power Tools, observability, some handlers, and generative AI. And dito, I don't think makita nyo to, pero this is some other use cases of Power Tools outside of serverless. Okay, so yun. Wala nang patumpik-tumpik pa. Refresh on serverless. Mabilisan. Ayun. So in the traditional workloads, the server-for workloads, you might see that you have to really focus on provisioning your own infrastructure. Your load balancers, your EC2 instances, things like that. And for some teams, provisioning those can be a bit of a hassle, bit of adding operational overhead to your team. Some teams just want to focus on shipping code fast without dealing with provisioning this, handling scaling, and dealing with the compliance requirements of those resources. So that's where serverless comes in. In serverless is built on top of the idea of ultra-managed containers, wherein scalability is managed for you by your cloud service provider. So we can see here that we now decrease the focus on provisioning our infrastructure with an increase in the application logic of our product, right? And as our application scales, as it grows, the cloud service provider handles the scaling for you. Ayun. And that brings us to the concept of scale to zero. While we can scale to infinity, we can also scale to zero, no? So if wala tayong traffic, essentially we just have $0 na AWS bill. That's serverless. And that is powered by the backbone, which is AWS Lambda. So AWS Lambda is a compute service that automatically runs your code in response to events without the need to manage servers. So you can run AWS Lambda workloads on any programming language, Ruby, Python, Node, or even your own custom runtime with Docker. So that's Lambda. So if you see here sa pricing model ng Lambda, it's always free up until a 1 million free requests per month. And chances are, if you're a small business, you won't reach that type of usage, right? You won't reach that type of traffic. So serverless is really cost-effective in that way. All right, so now we've seen the benefits of serverless, right? Now, here is the traditional na serverful workloads. This now shifts into an infrastructure that looks like this. Ano pansin nyo? Medyo kumalat, no? Medyo distributed. Mas maraming services from everywhere. So what we see there is that each route of our REST API, for example, is essentially mapped into a single deployable unit, a single Lambda function. So yun, sobrang distributed niya. Ayun. So, okay, so we've seen the run-through of serverless. Now, that begs the question, what does a well-architected serverless application look like, right? Luckily for us, there is a service called, the Well-Architected tool. So the Well-Architected tool is a service in AWS that allows you to diagnose your own resources and then check if it goes against the best practices brought by AWS. Ayun. So this is the first page ng console. Just put the name of your workload, the description, and then you can see here, you can select different kinds of lenses. So lenses are the different criteria depending on your workload for it to be, let's say, for it to be deemed well-architected. So by default, we have the well-architected framework na lens. There's also a serverless lens if you have a serverless workload. If you want to assess the well-architectedness of your DevOps team, you can use the DevOps lens in the well-architected tool. Ayan siya. All right, so here is the serverless lens. When we look into this further, you see that ito yung mga questions niya. This is the first step, so operational excellence. How do you evaluate your serverless application's health? So what we see here is that you can answer that and meron kang ma-reveal a dashboard for you if it matches the pillars of the well-architected framework. Ayun, by just answering those questions. Okay, so balik tayo dun. Balik tayo dito sa questions. Operational excellence. First question, does it have metrics? Okay. Does it have distributed tracing? Does your serverless workload have structured and centralized logging? Ayun. So, question number 1 pa lang yan. So, if you want to build those capabilities, so we can, fortunately, have AWS services that handle that for you. For distributed tracing, we have AWS X-Ray, and for metrics and logging, we have Amazon CloudWatch. So let's try to implement this. Structured logging. So in structured logging, what you see there is that our logs for our whole application has a defined and predictable schema that we can essentially search through. So if alam natin yung structure ng logs natin, and we see that there's an error in production, right? We can just use the CloudWatch Insights tool to search through our logs like that. And you can set up something like an alarm wherein each log goes against this filter. And then if nag-match yung filter na yun, meron parang Slack na notification and ma-alert ang dev team natin. So it's like that. So how can we implement this, no? With Python. So this is how you implement structured logging in Python. It's not as straightforward. So every programming language has a standard library for implementing logs, but it's not structured. You have to define the structure yourself. So here, ang mangyari dito is you override the formatter class sa Python with your own na structure. And this is just the first part of the code, just defining the logger instance natin. And then you invoke that logger.info for every piece of the logs. Okay, so that's how we natively set structured logging. How about tracing? Ayun. So AWS X-Ray essentially is a service that allows us to view the workflow of each component of our serverless workload. So for example, as we established, diba, serverless, it's inherently gaining more distributed, diba? So if ever merong error sa application natin, you can see that there are multiple points of failure. Saan ba yung component na nag-fail? With just logging, di natin makita yan, right? But tracing allows us to do that easily. It allows us to get the flow of the invocation. Ano ba yung Lambda function? Ano ba yung service na kinocall niya? And saan siya nag-error? And we can also track ano yung duration for each invocation. So essentially, we can track cold starts, for example. Ganun siya. How can we implement this in Python? We do a pip install of the AWS X-Ray SDK. Ganun siya. We install that and we do this code. Ayun, medyo mahaba, right? So yun, we import the X-Ray recorder na library in in X-ray SDK, and then we use that with clause in Python to essentially put on the entire scope of our application dun sa with clause na yun. So parang if ever meron kang Lambda function, ilalagay mo talaga sa with clause yun. Wala kang choice. That's how you do it natively, which is not really a good way to structure your code. Okay. How about metrics? So metrics again is a way to measure some components of your application, things like CPU utilization, memory, and network bandwidth, things like that. So if ever that you have a metric, you can measure, for example, how much memory am I using for this function? And right size it compared sa kung gaano siya nakaset. So makasave ka ng cost if you have like a memory metric. So here, this is how you structure, this is how you do metrics natively in Python. Medyo mahaba, I will not go through this any longer. Okay? So as you can see, if you want to implement these best practices, if we want to implement these best practices, most teams would just put that on the back burner, diba? Okay, I just want to focus on my product. Let's just focus on these well-architected characteristics of our application later on before we operate. And for most teams, later never comes. All right. So what if there's a way to implement best practices from the build step lang? What if there's a way to make all of those monitoring solutions much easier? So let me introduce to you AWS Lambda Powertools. So AWS Lambda Powertools is a set of libraries, a set of utility functions that allows you to implement best practices in serverless applications much easier. So marami siyang features. This is the documentation of Powertools. Sobrang rami niya. And all of these parts of the library will help you implement those best practices. Sorry. So how can we implement monitoring in our Lambda functions with Lambda Powertools? First, we do the pip install ng Powertools. Ayun siya. So this is how you do structured logs. Pansin nyo, medyo kakaiba na. We just import yung Lambda context and yung logger doon sa ating Lambda Powertools. We create an instance of that, and then suddenly, we just add that one line. Yung one line lang na yan, that decorator syntax sa Python. And then you can just invoke your structured log in one line of code. Ganun siya ka-easy. How about distributed tracing? We now see that same pa rin. Instantiate the tracer na object and then add that one line of decorator syntax for each Lambda handler. You add that to each Lambda handler sa yung serverless workflow, and then you see na, okay, I now have distributed tracing implemented with just this code modification. How about metrics? Ito yung original, the native way of implementing metrics in Python. Now, how do we implement this with Powertools? Ganito lang. We just, again, instantiate the metrics from Powertools and add that decorator syntax. It's that easy. All right, so those are the features of Powertools for observability. However, Powertools goes beyond observability. It has things like feature flags, streaming, idempotency. Yung idempotency, by the way, ang favorite kong feature. So yun. But I want to focus on the event handler na feature ng Powertools. So with event handlers naman, as we established that as serverless applications are actually inherently more distributed, we see that we can do this. We can have an event handler. We instantiate the API gateway REST resolver and add a decorator syntax for the route and deploy that into a single Lambda function. You can have multiple parts of these decorator syntax, itong app.get. You can have an app.post, app.put, just like your REST APIs. And the paradigm shifts from the distributed na single-purpose functions into this. So that's one option possible in Powertools if that fits your use case. But the best part about this is not the Lambda lift paradigm, it's this. The automatic generation of Open API documentations. So if you don't know, Open API is like a way for you to document your RESTful endpoints in a way na easily lang ma-understand ng development team mo. For example, ang backend team mo tapos na sa isang endpoint and dapat ma-consume na siya ng frontend team. You just give the documentation and then ma-invoke na siya ng front-end team easily for faster implementation. Ayun siya. So, under the hood, itong code na na-generate niya. Alright? So, take note from this code, all the way, naka-generate siya ng this code. That's the power of Powertools. So, I want to dive more into generative AI. Okay, so I won't dive deep into this kasi merong talk on Bedrock agents. But Bedrock agents is essentially a way for your LLM to invoke your APIs. Ayun siya. So you describe how each endpoint is used to your LLM, and siya na bahalang mag-invoke niyan depending on your use case. So you can have your LLM do some automated work for you without having any human supervision. All right. So to define an agent, we essentially define the name, the description, what does it do, IAM permissions, of course, and then define our LLM being used. In this case, it's Anthropic. And then we define our action groups. Action groups is yan yung mga RESTful endpoints na ma-invoke ng ating LLM. So in this case, we just put in the name, the description, anong ginagawa ng action group na to. The Lambda function that it invokes, and yung S3 object kung saan nakalagay yung openapi.json. Familiar? So, yun nga, openapi.json is very long, very verbose actually. All of this code is just for one endpoint. So if you want to implement this mano-mano, mahirapan ka talaga. That's why, thankfully, Powertools provides us the way to easily generate this as we established kanina. So what you can do is that, once again, just instantiate the Bedrock agent resolver from Powertools, add that decorator syntax for scheduled meeting, and then yun, mabasa na siya ng Bedrock agent natin. It's that easy. So what the best part about this is that it also has validation, all right, input validation. So if ever na by any chance yung LLM natin naka-create ng isang payload sa API na hindi nag-match sa expected, mag-return ng error yung API natin, and then mag-retry yung LLM with that response niya. So that's so cool. Alright, so those are some features of Powertools. Ito yung full list if you want to dive deeper into that. But also, Powertools goes beyond the AWS Lambda. There are also use cases for Powertools that, for Fargate, for example, this is like an issue sa GitHub wherein a team has requested sa Powertools team na, okay, hi guys, can you enhance the support for Fargate? Ganun siya. So it's not useful. They found a utility for the API handlers, for the logging and metrics outside of Lambda. And much more, the utility of Powertools just goes beyond software development. Data engineers can use Powertools for their ETL workloads, the data validation library. Platform engineers and security engineers can use the guardrails and yung feature flags of Powertools. And data scientists can use the structured logs for their Jupyter notebooks. That's some use cases for Powertools that we've seen out there in the wild. It's pretty weird, but it works. All right, so here's the full documentation of Powertools if you want to learn more. And that's pretty much it for my talk. Thank you. All right, so here's my profiles if you want to scan, if you want to connect. Just 1, 2, 3, and that's it. And plug ko lang, on November 30, we have a meetup for Durian Pie and PWA Pilipinas. So you can pre-register now with this QR code. So yeah, see you guys there. Thank you.